Okay, Assalamualaikum. Since sekarang ni COVID-19, so kita tak boleh nak buat kelas sangat. So this is the first trial untuk kita buat kelas secara online melalui approach YouTube lah. Hopefully it's benefit to all of us. Alright, so subjek kali ni adalah still thermodynamics. Kita continue daripada kita punya kelas yang lepas. So last class we already look about a few topics about pure substance and how to read the property table from the books. To be exact, it's the steam table. How to find numbers and also how to interpolate the numbers. And today kita continue a little bit about an ideal gas equation of state lah. This equation is not something new equation. It is something yang you dah tengok pun before, in which is PV and RT, ideal gas law equation, where you know already P is your pressure, V is your specific volume, in which it is equal to the R ataupun universal gas constant and the temperature of the gas itself. So every gas, every pure substance will have its own R value. So it's very specific. So you need to know what is the how the gas react. But the universal gas constant, the value itself that we like to use is 8.31447 kilojoule per kilomole K. The ideal gas law only apply for when you have a gas and the gas need to be reheat again to form the superheated steam, for example. Then that superheated steam will follow either will follow the ideal gas law or slightly varies from the ideal gas law itself. But don't worry about during the saturation point. Where the saturation point, you know already the temperature will not change. Therefore, the gas itself will not change due to equation of PV and RT, in which the T is not changed. So the V will fix throughout until it's reached to the saturated vapor point. After saturated vapor point, in which the superheated gas, then only you can calculate for it. Of course, not all gases is actually an ideal gas. It will follow the ideal gas condition. The real gas somehow varies a little bit, in which the real gas we can represent it by compressibility factor of Z, in which it is the volume of the actual gas over the volume of an ideal gas. If an ideal gas, the Z should equal to 1 and only 1. But somehow when you calculate the specific volume of actual and also ideal, you will find out that the numbers is not actually 1, it varies. It's deviate from 1, either it's lesser than 1 or lower than 1. It means that the more the value deviates from the value of 1, it is most likely did not follow the ideal gas law. However, that's the real gas. Alright, you can refer to your slide number 37. It shows you the comparison of Z factor for the various gases. Somehow it shows, give you some idea of it. The next one, the equation of state, the ideal gas law is not, even though PV equal to RT is the most popular one, but there are several equation that you still need to know. For example, the van der Waals equation of state, in which the equation is given in slide 37. So you can refer on that, and we have a few more equation that available. For example, we have the Bridgman equation of state. We have Benedict-Wells virile equation of state, and so on. So these are the things that you need to read about and to know about it. Alright, just to wrap up what we have learned from the previous class and today's class, we are talking about the pure substance of, well, how the pure substance react when you give heat to it. So it involves the changes of phases. So you know that from the beginning, the pure substance, let's say, started with a compressed liquid, and it been heat up, the temperature rise up to the point where it reached the temperature of saturation. And that temperature of saturation, that's the point where the liquid is starting to change its phase from liquid form to a gas form. And during this process of changing, the temperature will not change. As long as there is a liquid, the temperature will not change until the liquid fully vaporizes. After the liquid fully vaporizes, then only if you supply another heat, the steam itself, the gas itself will undergo a higher level of steam, in which we call it a superheated vapor. In this part, each and every one of you need to know the terms of what is a compressed liquid, saturated vapor, superheated vapor, saturation temperature, and saturation pressure. This is something that must be always in your mind, and when this term is called, you know where it is. Also, as a chemical engineer, we need to know a few diagrams. For this topic, we have a TV diagram, we have a PT diagram, we have a TP diagram, and also PVT surface diagram. Well, all this diagram, when you want to find the figures or when you want to find the numbers, it's already been discussed in the previous class, saying that it is not something that you can have a one equation to solve everything, but at the end we still need a table to find numbers. So inside the property tables, steam tables, there are, well, a lot of table actually inside that. We have A4, A5, A11 for A4, A5, A6 for steam or water, and 11, 12, 13, that one is for refrigerant 134A. Inside all these tables, there are values that need to be read. For example, the specific volume values, and this specific volume has two values actually. One is VF and VG. Same goes to the H, same goes to the S, and same goes to the U. All have UF, UG, UFG, and so on and so forth. Well, hopefully after this class, you still remember how to read the tables, how to interpolate, because not all numbers is actually right on the dot stated in the book. Eventually you will come out, or you will face another number in which in between a temperature that is stated in the steam table. Then you need to interpolate. Don't worry about interpolation. Interpolation is very easy things, even though if you try to memorize the equation, somehow you will have a problem when you want to solve it later. So let's understand how interpolation works. It's just a concept of linearity, means that you find the slope of the difference and you find the third one based on that slope. Alright. So that's all about the pure substance topic. Hopefully it's helped you a lot. We have a few tutorials after this that will be on the next class or the next video. Thank you very much.